Hello and welcome to the course of Heat Engineering. This is unit 2 Convection. In this unit, we will look into the details of convection, its mechanism, and its various applications. So, as we know that the convection is the heat transfer in the presence of fluid motion over a solid surface. So, the convection is the bulk motion of fluid. The various mechanisms which plays its role in the convection heat transfer are advection, diffusion, and heat generation. Advection is the physical transport of the fluid. So by the virtue of movement of the fluid particles, the heat is transferred from one coordinate to other. Diffusion. So diffusion is the molecular phenomena in which the neighboring molecules transfer uniformly in all directions to the other fluid molecules. The heat may also be generated due to the fluid friction. So like the convection also requires the presence of material medium and the motion of but the convection requires the motion of the fluid. So we already know that the heat transfer through a fluid is by convection in the presence of the bulk fluid of motion and by conduction in the absence of the bulk fluid motion. So if there are convection currents which are responsible for the bulk fluid of motions, on this basis the convection can be defined as forced convection and natural convection. So in natural convections, you can see that once the colder fluid comes into contact of hot solid surface, it gets warmer. So its density becomes less and it becomes lighter. So these heated fluid particles rises up and giving the place to the heavy cold particles. So this process continues, and in this process we do not need some external agency. So this process is known as natural convection. So natural convections are basically governed by the buoyancy forces. In case, for example, if we attach a fan to cool our food or some hot things, that will be termed as forced convection. In forced convection, the fluid is forced to flow over a solid surface. So in this case, the heat transfer rate increases. The fluid motion enhances heat transfer because it brings the warmer and cooler chunk of fluids into contact and thus initiating the higher rate of conduction at a greater number of sites in a fluid. The rate of heat transfer through a fluid is much higher by convection than it is by conduction. So this rate of convections and the amount of rate of heat transfer through convection depends upon the various parameters. For example, higher the fluid velocity, higher will be the rate of heat transfer. So the rate of convective heat transfer strongly depends upon the fluid properties like dynamic viscosity, thermal conductivity, density, and the specific heat as well as the fluid velocity. Higher is the fluid velocity, higher is the convection rate, lower is the specific heat, higher is the convection rate. Higher is the thermal conductivity of material, higher is the convection rate. It also depends upon the geometry and the roughness of the solid surface. The rate of convection heat transfer also depends upon the type of fluid flow. A turbulent flow will typically increase the rate of heat transfer because the highly disordered motion of the fluid particles enhance the rate of heat transfer and from the solid heated surface to the cooler fluid. So as I have told you that the convection can be categorized as the free or natural convection, which is primarily induced by buoyancy forces, or forced convection, which is driven externally. So the heat transfer rate in convection can be easily calculated by using Newton's law of cooling, where the heat transfer rate can be given as Q is equal to H and the temperature difference between the solid surface and the fluid temperature which is coming over it. H is known as heat transfer coefficient. H is unlike the thermal conductivity, where the thermal conductivity is the material of property of a material, solid or fluid. H is not a property of the material. It depends upon the nature of flow and other thermodynamic properties and various other parameters. Also, it depends upon what type of convection is taking place. For example, the typical values of H can be calculated as in gases free convection 2 to 25 and for the liquid 50 to 100. So you can see also that the heat transfer coefficient is higher in case of liquid. And in case of forced convection, you can see that the for gases the value is 25 to 20 to 50 and for the liquid it is much larger than the gases. And also in case of boiling or condensation, you can see that it is very high. So Newton's law of cooling. So Newton's law of cooling is observed to be the proportional to the temperature difference. It says that the rate of convective heat transfer can be calculated by multiplying the heat transfer coefficient with temperature difference between the heated solid and the ambient fluid coming over it. So to calculate the heat transfer rate, it has to be multiplied by the exposed surface area. So Q dot convective can be given as HAS Ts minus T infinity, where AS is the heat transfer surface area over which the heat transfer through convection is taking place. No slip condition. So let us move to another concept which plays its crucial role in heat transfer at the solid and fluid interface. A fluid In direct contact with the solid sticks to the surface due to the viscous effects and there is no slip. So the fluid layer adjacent to the solid blocks assumes the velocity of the solid block. This is known as no slip condition. Also, the fluid and solid surface should have the same temperature at the point of contact. There is no difference because of the thermal equilibrium developed at the solid fluid interface. So this is known as no temperature jump condition. So we can write that at the solid surface, velocity of the fluid is equal to velocity of the wall and temperature of the fluid equal to temperature of the wall. What are the implications of no slip condition at solid surface? So at the solid surface, because there is no movement of the fluid particles, so the heat transfer from the solid surface to the fluid layer adjacent to the surface is by pure conduction and can be calculated by using the typical Fourier's law, that is Q dot convective equal to Q dot conductive conductance at the surface, that will be equal to minus K of the fluid del T over del Y at the solid surface, where Q dot is heat flux. So this can be equated with Q is equal to HA del T, and thus we can calculate the heat transfer coefficient by this formula experimentally. So scientists and engineers have performed experiment to define or calculate the heat transfer coefficient for various configuration and type of flow, and also for the different type of convection, that is a natural convection and free convection. So we can know that this H can be calculated if the temperature distribution is known along the y direction in the fluid, and K of the fluid we will know, and the temperature of the solid and temperature of the ambient fluid is known. So how can we solve a convection problem using the basic equations? So there are three basic equations of fluid mechanics will be used, which is the conservation of mass, conservation of momentum, conservation of energy. Just because in convection the movement of the fluid is necessary. So we have also use the conservation of mass and momentum. However, you have seen that only the conservation of energy principle is applied in conduction problems. So in convection, all the three governing equations need to be solved. So a large number of parameters are involved in this process. So we have classified the type of convective flows and we have modeled different type of convective flow to solve it conveniently. So there are several parameters which are involved, like the fluid properties, geometry, nature of flow, phase, etc. We must identify each and everything of these, whether the flow is natural, force, and what are the phase of the fluid when it comes into the contact of the solid surface, heated solid surface. What is the nature of flow, whether it is turbulent or laminar. So all of these informations are required whenever we want to solve the convective flow problem. And based on these information, we classify the flows into certain types and based on certain parameters. So the various parameters are grouped into the meaningful non-dimensional number, for example, Prandtl number. Note at and we have to understand the physics behind each of these type of flow and apply the appropriate boundary condition and solve the governing equation to arrive at some conclusion. So the fluid flow in convective heat transfer can be classified based on geometry like external flow or internal flow, based on the driving mechanism whether it is natural convection, forced convection, or it is a mixed convection in which both type of convection is taking place. Based on the number of phases, whether it is a single phase heat transfer or in the process of heat transferring, the phase change of the materials also take place. Based on the nature of flow, that is laminar flow or turbulent